Welcome back, guys, another Jacob Visions video. As requested, to fill in some of these holes about electromagnetism, we're going to go through the whole thing, and I'm going to show you in real life, just like we did in class. Pause it, take notes, come back to it. Here we go. Electromagnetism. You know, electricity, magnetism, they're like cousins, right? But what does it mean when I say electromagnetism? Why is it important? Well, you just need to remember one thing. If I move electricity, I make a magnet. And if I move a magnet, I create electricity. And that's how this whole world is working right now. That's literally how it's all working. And I'm going to show you that. First, a basic electromagnet. You saw this already. You might have seen it in a television show like Breaking Bad or something like that. You might have seen this, this junkyard thing pick up a bunch of ferrous metal parts and then be able to drop them. Well, how do you turn off and on a magnet like that? What's going on here? Well, this is an electromagnet. I'm going to show you. Come right over here. So, I'm going to take a 1.5 volt DC battery called a D cell right here. And I'm going to grab a copper coil. And we call this a solenoid right here. And all I'm going to do is I'm going to take something that has iron in it, like this ferrous iron steel rod. And I'm going to slip it through the solenoid. And then I'm going to create a simple series circuit, not a parallel circuit, a series circuit. And as you know, when the circuit is closed, current is going to flow through it. So here's the key. When current flows through something, when electricity moves, it creates a magnetic field. Now watch this. This is not magnetic. See? Nothing special about it. However, when I move current through it, like so, it becomes a magnet, like this. The moving electricity creates a magnetic field. Now I can turn that off. See how useful that is? That's exactly what's going on here. This is just a big version of that. But this should show you, prove to you, if I move current, I create a magnetic field. Now, let's talk about the polarity of this. You know magnets have a north pole and a south pole, just like the Earth, because the Earth is a giant magnet. Well, what's the polarity? What's the north pole and the south pole here? Well, there's a very easy way to figure that out. All you have to do is think about which way the current is flowing, and that's your hand, right? Your fingers like this. So if the current is flowing like this, if you stick your thumb out, that's the north pole, just like this. We'll do that the next time I see you in class. Very easy. It's called the right hand rule. You got to know it. Now, let's flip that around. If I told you if I move electricity, I create a magnetic field, what can we do with that? Now, let me just show you one of the most famous ways that we use it. I just have a AA battery right here. Check this out. Copper wire. If I connect it here, what's that? A simple series circuit. Now, what if you know that if I connect this, it's going to create a magnetic field, right? Just like I just showed you. What if I put another magnet near it, right? So here's some neodymium magnets. They're very strong. Now this is going to be a magnet and this is going to be a magnet. Let's see what happens when we put them together. So pay attention. Can you see this? All right. So I have an electromagnet and a regular magnet. What's happening here is the magnetic field that I created with the electromagnet is hitting the magnetic field of the actual neodymium magnet, and they're deflecting, right? Because north and south want to attract, but north and north want to repel. So what's happening here is this constant magnetic repulsion that's causing an electromotive force. Now this is exactly how all these electric motors work. Like in this fan right here, moving these blades, that's exactly how it is. There's no gasoline powering this. It's just a magnet moving around an electromagnet and being deflected by it. Just like this fan. This fan's not wired up right. That's funny, right? Or your kitchen appliances, or even a Tesla. That's exactly how this works. So the thing you got to remember is this. An electromagnetic motor takes electrical potential energy and turns it into motion, right? That's very important because we want to move around, right? I need a fan right now. Whew. What can move the fan? Well, if I energize an electromagnet and put it next to a magnet, it's going to start spinning it. That's exactly how it's going to work. All right. So something even sweeter and more important is the opposite. What if I don't have a battery and I don't need a battery, but I want to turn on my lights, right? What I can do is take the same principle and reverse it. So what happens if I move a magnet, right, around a conductor like this? Well, what happens is I induce the magnetic field, right? If I move electricity, I create a magnet. But if I move a magnet around a conductor, I create electricity. And that's exactly how we generate power, right? And that's called the electric generator. It's the opposite All you got to do is think, if I move electricity, I create a magnet. If I move a magnet, I create electricity, right? And if the motor takes electrical energy and turns it into motion, the generator takes motion and turns it into electricity. You've seen this, like that. What's inside there? A big electromagnet, right? So the wind, the energy from the wind, is turning that magnet, right? And that magnet, close to a conductor, is inducing electric current. And that's how we're creating electricity. So nothing's for free. You just can't create electricity. We're just turning the motion of the wind, right, which came from the sun, the uneven heating of the Earth's surface, and we're using it with the principles of electromagnetism to harness electricity. That's how we have all of this. Literally all these lights come from a power plant that uses either coal or something like that to boil water, to create steam, to turn a turbine, to move a magnet around an electromagnet, and boom, we induce a current. That's how it works. Last but not least, transformers. Now, once you understand how that works, it gets a lot more complicated. A transformer comes in when we want to move that electricity really far distances. We like to keep it at very high voltages, right? Not like this battery that's 1.5 volts. We're talking about like 500,000 volts. Now, how do I get it from the power plant that I told you up to your Xbox, right? Well, your Xbox doesn't need 500,000 volts. It needs like 110 volts, maybe even less. Well, how do we get it from high voltage to low voltage? We use electromagnetism, and it's called a transformer. And it's not Bumblebee or Optimus Prime or a Decepticon. It's a transformer, right? And it's built on this principle, right? Check this out. If I have an electromagnet here, right? This is just an iron bar, and I have some coils, some solenoids, just like this, right? If I move electric current back and forth, that's called alternating current. And now, you know from the principles of electromagnetism, if I move electricity, what do I create? A magnetic field. And because it's going back and forth, the magnetic field changes back and forth. And that induces a current in a secondary coil. It, like by magic, induces current in this other coil. Now here's where the magic comes in. If I've got a lot of coils over here, a big solenoid, and less coils over here, a small solenoid, it actually steps down the voltage, right? That's how that works. So this big voltage from the power plant can become small voltage that goes into your laptop or your cellular phone. That's what's inside here. That's what that's doing, right? It makes it safe. But it has to work with AC power, alternating current. Why? Because it needs to change that magnetic field, right? That moving magnetic field is going to induce the current moving back and forth, and that's going to induce the current moving back and forth in the secondary coil. That's how it works. That's the transformer. Also, we're talking about energy vampires because we know that the alternating current is moving back and forth all the time. It's always drawing power. Always. Even if your electricity is, or your device is already charged, this thing is drawing power 24/7 because of electromagnetism, because of how the transformer works, and that's it. All right. If you have any questions, come see me. Do the video questions, 10 questions. I expect you to do it by Monday. Let's get it.